Alright, in this one we're going to try out a non-standard inner product on vector space R3. So on R3 we're going to define the inner product of two vectors to be the sum of the product of their first components plus 2 times the product of their second components plus 3 times the product of their third components. This is an inner product. It does satisfy all of the axioms. However, we're not going to be proving that here. So for part A, I would like to find the distance between vectors w and v, where w is the vector 5, negative 1, 2, and v is the vector 2, 4, negative 3. Now the distance between two vectors is defined as the magnitude of the difference of those two vectors. So first thing we're going to do is actually subtract these two vectors. And since we're doing w minus v, we'll go component by component. 5 minus 2, that'll be 3. Negative 1 minus 4 for negative 5, and 2 minus negative 3 for positive 5. Now, this is defined as the inner product, or rather the square root of the inner product of this vector with itself. So 3, negative 5, 5, with 3, negative 5, 5. So we're going to see some extra multipliers as we're taking the inner product of these vectors together. So square root of, now according to our inner product up here, I multiply their first components together. That'll be 3 times 3. Then I'm supposed to take 2 times the product of their second components. So that'll be 2 times negative 5 times negative 5. And then 3 times the product of their last two components. So 3 times positive 5 times positive 5. And if we simplify this as much as possible, 3 times 3 will give us 9. 2 times 5 is 50. And 3 times 5 is going to be 75. Adding all of these things together, we're going to wind up with 134 under the radical. Now, that is not the distance between these two vectors using the standard Euclidean product, but that's not what we're doing here. We're working with a non-standard inner product. Now, continuing on, another thing that's very common when you have non-standard inner products is finding the angle between two vectors. Now, for this, we're going to need the following formula, that the cosine of the angle between them is going to be the inner product of v with w divided by the products of the magnitudes of these vectors. So let's start with the inner product of v with w. Now again, according to our non-standard inner product, we're going to be multiplying the first components together, doubling the product of the second components, and tripling the product of their third components. So with that in mind, first components multiplied together will be 2 times 5 plus 2 times. Product of their second components will be 4 times negative 1. And then 3 times the product of their third components, which is negative 3 times 2. That's going to be 10 minus 8, which is 2, minus 18 for a total of negative 16. For the magnitude of v, very similar to what we did above, we're going to multiply the first component of v by the first component of v. Then we'll do 2 times the second component of v times the second component of v. And then 3 times the third component of v times the third component of v. And again, this is because we have our non-standard inner product. So inside the radical, we're going to see 4 plus 32. 32. It'll be 36 after we add them together. Plus 27. So 36 plus 27 will be 63, and if we want to simplify that radical, we can call that 3 square roots of 7. Finally, for the magnitude of w, this calculation will look very similar. So we multiply first component by first component, that's 5 times 5, plus 2 times the product of the second component with the second component, plus 3 times the product of the third component with the third component. 5 times 5 will give us 25. 2 times negative 1 times negative 1 will give us 2. 3 times 2 times 2 will give us 12. Adding all this together will give us square root of 39. According to our formula, this means that the cosine of theta is going to be equal to the inner product of the two vectors, negative 16, divided by the product of their magnitudes. So 3 square roots of 7 times the square root of 39. Now this means that the exact value of theta is going to be the arc cosine of negative 16 over 3 times, let's see, the square root of 273. And if you really want to annoy an engineer, you just leave it like that. Yeah. Or, toss it into a calculator. That would work too. I thought about doing it. I was really close. So that's going to be negative 16 divided by 3 square roots of 273. Notice that I'm putting the entire denominator inside parentheses because there is an implied grouping symbol down there. Make sure my calculator is in degree mode. And we get this nice little obtuse angle right here. So this is about 108.83 degrees. We'll round out the second decimal place just for funsies. So there you go.